Okay, now let us discuss question number 43 from the practice sheet. Question number 43 says, an oil funnel made of tin sheet consists of a 10 centimeter long cylindrical portion attached to a frustum of a cone. If the total height is 22 centimeters, diameter of the cylindrical portion is 8 centimeters and the diameter of the top of the funnel is 18 centimeters, find the area of the tin sheet required to make the funnel. Okay, so let us try to understand the question using the diagram given. It says that this is an oil funnel. In this oil funnel, there is a cylindrical base, okay, cylindrical portion which is attached to a frustum. So let us try to draw the diagram. There is an oil funnel which has a frustum at its top like this, and this frustum is attached to a cylindrical portion. It's a cylindrical long portion or the bottom of this funnel. Okay, you can see this is a cylindrical funnel. This is the cylindrical portion of this funnel and this is the frustum. Now it says that it consists of a 10 centimeter long cylindrical portion. So the length of the cylindrical portion, now how to calculate the length of cylindrical portion? It is the distance between its two faces. Since this base is same for the funnel as for the frustum as well as for the long cylinder, then I can say that both the bases are attached to each other. It means this base is a common base and the radius of this base for the cylinder is same as that of the frustum. Okay, same as that for the frustum. Now it is given that the cylinder is 10 centimeter long. Now the cylinder is 10 centimeter long. Further it says, if the total height is 22 centimeters, so total height of this funnel. So total height of this funnel will be measured from the top of the frustum, okay, to the bottom of the cylinder. Okay, the top of this frustum and bottom of this cylinder, not of the frustum. Okay, so from here I will measure the bottom. So this height is given as 22 centimeters. So if this is 22, then what is the height of frustum? I can calculate the height of frustum. It is 22 and this is 10, so 22 minus 10 is 12 centimeters. So this gives you the height of frustum. Okay. Further it says the diameter of the cylindrical portion is 8 centimeters. This is the cylindrical portion, its diameter means its width. Okay, its wideness of this cylindrical portion, how much this cylindrical portion is wide, and this represents the diameter, and the diameter is 8 centimeters. Now since, as I have told you that the cylinder and the base of this frustum, this cylinder and the base of this frustum is common here. Okay, you can see this is common for frustum as well as for the cylinder. That's why I can say that this 8 centimeter is also the diameter of this base of the frustum. Okay, so I can say this diameter, this particular diameter is also 8 centimeters. Okay, this is also 8 centimeters. Further it says the diameter of the top of the funnel. This is the top of the funnel and the diameter of this top is 18 centimeters long, like this. Okay, it's 18 centimeters. Find the area of tin sheet required to make the funnel. So how much tin sheet is required to design this funnel? Now again think like a worker. The worker who is making this funnel, how will he think? He has to make a funnel which has a cylinder at the bottom and a frustum at the top. So he will think that I need to have a sheet, I need to have metallic sheet such that I can make the cylinder and I can make this frustum. Now, in this cylinder and the frustum, what he need to make? He just need to make the walls of the cylinder and the walls of the frustum. Do he need to make the top of the frustum? No, because it's a funnel, so definitely this top is open. Now, do he need to make the bottom or the base of the funnel? Again no, because it's a funnel, so this base where the cylinder and the frustum are joined is also open. And similarly, this base of cylinder, do he need to make this base? No, he need not to cover this cylindrical base. So what I will say is that this top is open, this base is open, or the top of the cylinder, and this base of the cylinder is also open. So all the things are open. Okay. Now, if I want to calculate the area of, what we need to calculate, area of tin sheet. Area of tin sheet required should include, now what should be included in area of tin sheet? The area of sheet that is required, I need to have, first thing that need to be included is the walls of the frustum. The walls of the frustum constitutes the curved surface area of frustum. So definitely area of tin sheet required should consist of curved surface area of frustum. And what is the formula for curved surface area? The formula is very simple, we have discussed it n number of times, that is pi L R1 plus R2. Now what is L? L is the slant height, R1 and R2 are the base radius. Okay, so the radius of this top will be, let us say this is R2, which is 9 centimeters, okay, because diameter is 18, so radius is 9. Similarly, the radius of the base, radius of the bottom is R1, which is, the diameter is 8, so radius will be 4 centimeters. Okay, the one thing left is slant height L. So in this case, where should I mark the slant height? This is the slant height. Okay, this represents the slant height of this frustum, and we know the formula to calculate the slant height. Let us calculate it here only. Slant height L is equal to square root of h square plus R1 minus R2 square. Okay, this is the formula for slant height. H represents the height of frustum. I can see height of frustum we have just calculated, which is 12 centimeter, and the radius of top and the bottom are 9 and 4 centimeter respectively. This will be equals to square root of h square, h is 12 square, plus R1 minus R2, that is 9 minus 4. So I am writing directly as 9 minus 4 is 5, and square of this, which is equals to square of 144 plus 25, which is equals to square root of 169, and which is again equal to 13. Okay, because 169 is a perfect square, and the square root of 169 will give you 13. Okay, so we have the slant height, we have the radii. Okay, so we can calculate its curved surface area. Now the second thing that we need to include in the area of tin sheet, what the worker has to make, one more thing, he need to make this cylinder. As I have said, he just need to make the walls of this cylinder. So what is the walls of cylinder? The walls of cylinder constitutes its curved surface area. So definitely in this area I need to include the curved surface area of cylinder as well. Okay, I need to include the curved surface area of cylinder as well, and curved surface area of the cylinder is 2 pi RH. R is the radius of the cylinder, which is 4 centimeters. Okay, and height of the cylinder is given as 10 centimeters. So finally I will write area of sheet required will be equals to pi L R1 plus R2 plus 2 pi RH, which is equals to pi I can take as common in L. L is 13 into R1 plus R2. R1 is 4, R2 is 9, so it will become 13 plus 2 into radius is 4 and height is 10. So this is pi. 13 square is 169 plus 2 fours are 8 and this is 80. Okay, so just add 169 plus 80. 160 plus 80 will give you 240 and 240 and 9 will give you 249. So I will say this area of tin sheet is 249 pi centimeter square. Okay, because the unit is used as centimeter, so this unit will be centimeter square. So this is the amount of sheet, the area of sheet that is required to make this funnel. Okay, it's a question of combination of solids as well as the frustum. The two concepts are merged and a hybrid question. That's why, since it's a hybrid question, so I will mark it as an important question. Okay. Okay, so this is the solution for question number 43. An easy question, but still you need to be very careful while solving. Okay, so you note this, then we will continue. Okay, let us now solve question number 44. Question number 44 says, a right circular cone is divided by a plane parallel to its base into a smaller cone of volume V1 at the top and a frustum of volume V2 as second part at the bottom. If V1 is to V2 is 1 is to 3, find the ratio of the height of small cone and that of the frustum. Okay, so let us understand the question. It says that there is a right circular cone. What I did is I divided this right circular cone into two parts. How? I cut it from the middle. Okay, I cut it from the middle such that there is a cone formed at the top and there is a frustum formed at the bottom. Okay, and the ratio of volumes of frustum and the cone is given as 3:1. Okay, so and the plane on which I cut this cone is parallel to the base of this right circular cone. Okay, so let us try to draw the diagram and understand the concept from the figure. It's a very good question. Let us say this represents the base of the right circular cone, and let us draw. This is the height of the right circular cone, and this represents the right circular cone. Okay. Now what I did is I cut this cone from somewhere in between on this height such that the plane of cut is parallel to the base. It means like this. Like this. I cut this cone like this such that this plane of cut is parallel to the base of the cone. Okay. So when I cut this particular cone in this manner, what I am going to have is I am going to have two parts. The two parts will be, one is like this, which is a cone, one of the part will be a cone and another part will be a like this. It's a frustum. Okay, so we have the two parts after cutting this cone into two parts, and the volume of this cone, the smaller cone, is given as V1 and the volume of this frustum is given as V2. Okay, the volume of cone is given as V1 and the volume of frustum is given as V2. And it says that V1 is to V2 is 1 is to 3. So what is given as V1 is to V2 is 1 is to 3. Now what does this mean? V1 is to V2 is 1 is to 3. What does this mean? It simply means that volume of frustum is 3 times volume of smaller cone. This is what you can understand, because V1 represents the volume of smaller cone, V2 represents the volume of frustum, and when I cut these two cones, when I cut this cone and have two parts, it is divided in manner that the volume of this frustum is 3 times the volume of this cone. Okay, so if I say that what is the height of the frustum? What is the height of the frustum? Let us say HF represents the height of the frustum. Okay, and if I ask what is the height of the smaller cone, this is the smaller cone. So the height of smaller cone will be HC. So HC represents the height of the smaller cone and HF represents the height of the frustum. This is the frustum that we have. Okay. Now if I ask you what is the height of the, if I ask you what is the height of the larger cone, I can see HC represents the height of smaller cone, HF represents the height of frustum. So height of this larger cone, height of this larger cone will definitely be sum of these two heights, that is HC plus HF. So HC plus HF represents the height of larger cone. Okay. Now let us understand the question further. It says find the ratio of the height of small cone to that of frustum. So what we need to determine? To find, we need to find height of smaller cone is HC and height of frustum is HF. We need to determine their ratio. So our task is to determine HC upon HF. Okay. So now how should I start? From where should I start? It is only given that this is a cone, the cone is divided into two parts, but there is a condition given that volume of frustum is 3 times the volume of smaller cone. So there is a smaller cone and a frustum. And if I look at the figure from a general observation, I can see how I have made this frustum. This frustum is made by deducting this smaller cone from the larger cone. Okay. So what I can see, there is a relationship of volume. Okay, there is a combination of solids, the concept of combination of solid. I can see that from this larger cone I have deducted this smaller cone, I have removed this smaller cone. It means definitely the volume of this frustum might be related to the smaller cone and the larger cone. Okay. Since I have deducted this cone from the complete cone to obtain this frustum, I can simply write volume of frustum is equals to volume of larger cone minus volume of smaller cone. Okay, I can simply write that volume of larger cone minus volume of smaller cone represents the volume of frustum. Okay, so in place of volume of frustum, here I have volume of frustum. In place of volume of frustum, can I write this value, volume of larger cone minus volume of smaller cone? Yes, I can write this. So in place of this volume of frustum, I am writing volume of larger cone minus volume of smaller cone, okay, is equals to 3 times the volume of smaller cone, okay, is equal to volume of is equals to the 3 times the volume of smaller cone. Now, what is the volume of larger cone? Let us consider that this is the radius of the larger cone and it is R1, okay, and this is the radius of the smaller cone. If I make this cone like this represents the radius of smaller cone, and let us say it is R2. So, volume of larger cone, this larger cone is 1/3 pi r square h. So, 1/3 pi r is the radius, that is R1, and what is height of the larger cone? It is hc plus hf. So, in place of volume of frustum, I have written volume of larger cone minus volume of smaller cone. So, volume of larger cone I can write 1/3 pi r1 square into height of larger cone, that is hc plus hf, minus volume of smaller cone. Volume of smaller cone I can write it as 1/3 pi r2 square into hc. This is the volume of smaller cone. This volume is equals to 3 times the volume of smaller cone. Again, the volume of smaller cone will be similar. It is 3 times 1/3 pi r2 square hc. Okay, that is the height of cone. In this manner I can write. Now, let us solve this. I can see 1/3 pi will cancel from all the sides, and here I will have r1 square hc plus r1 square hf, or let us remain this like this. Let us write it in the bracket only. Let us write it is r1 square into hc plus hf minus this is r2 square hc. r2 square hc is equals to, here I have 3 times r2 square hc. So, this will give you r1 square hc plus hf is equals to 4 times r2 square hc, okay, is equals to 4 times r2 square hc. So, from here I can see r1 square upon r2 square is equals to 4 times hc upon hc plus hf. This is what I can have, okay, r2 square, r1 square upon r2 square is 4 times hc upon hc plus hf. Now, I can see that to calculate the ratio of hf and hc, that is this ratio, this hc upon hf, to calculate this particular ratio, I need to have the ratio of r1 and r2. It means I need to somehow relate the ratio of r1, r2 and hc and hf. Why? Because I want to have a numerical value for hc and hf. So, what I am going to use is the concept that we have used to derive the formula, to derive the volume of frustum. That concept is, I can see if I say that this is A, this is B, this is C, this is D and this is E, I can very easily see that triangle ABC is similar to triangle ADE. Triangle ABC is similar to triangle ADE. Why they are similar? You can see this angle is common, okay, and this is 90 degree, this is 90 degree. That is why both the triangles are similar by a corollary, and therefore I can write AB upon AD is equals to BC, or let us write it other way. I will write it in this way, that DE upon BC is equals to, this DE upon BC is equals to AD upon AB. So AD, this DE is R1 upon BC is R2 is equals to what? AD is this complete height which is HC plus HF upon AB. Now what is AB? AB is this height, that is HC. Okay, so value of R1 and R2 is equal to HC plus HF upon HC. So in place of R1 and R2 I can write this equation. Okay, so here I can write it as, in place of R1 and R2 it is HC plus HF upon HC. So here I will write HC plus HF upon HC whole square is equals to 4 times HC upon HC plus HF. Okay, using this condition, using this particular condition, in this equation I can write this. Now just cross multiply, you will get HC plus HF whole cube upon HC cube is equals to 4. You can write this HC plus HF whole cube upon HC cube is equals to 4, which implies when I take cube root I will get HC plus HF upon HC is equals to 4 की power 1 upon 3. Okay, this is 4 to the power 1 upon 3. Then further I can solve it as 1 plus HF upon HC is equals to 4 to the power 1 upon 3, which implies HF upon HC is equals to 4 to the power 1 upon 3 minus 1, and from here I can get HC upon HF is equals to 1 upon 4 to the power 1 upon 3 minus 1, and this is the ratio of height of cone to that of height of frustum. Okay, HC upon HF is equals to 1 upon 4 to the power 1 upon 3, that is cube root of 4 minus 1. Okay, so you can see this question is a bit typical question. It's not easy to solve because you need to deduce this condition as well as this condition. So I know it's difficult to develop the approach, but you can develop this approach only if you solve multiple questions in this manner. Okay, if you solve such questions more and more, so you will get to know how to solve this kind of questions. Okay, the ratio or the relations where the numerical values are not given. So in this manner you need to solve this. Okay, so this completes question number 44, an interesting question. Okay, so you note this, then we will continue.